is equal to the sum of the two it doesn't touch. It's an easy one to do. Or if you had to work through the other way, you know that y has to be its supplement because of the line, so it gives you 30 here. You can add all those up to equal 180 as well. Excuse me. So if I say it's x plus 20 is 150, that gives me 2x, 130, and x is 65. So hopefully that wasn't so bad. Because it's x plus the 20. Or the outside angle is equal to the 2 it doesn't touch. 12, x has to be how much? 40. 40, very good. You're welcome. You know, I think he stole that calculator. He was hiding it the whole time. So. Look at the violence on the shoulders. No, you missed anything? So x and that one's got to be 40. That's easy. 13 again, pretty easy. That value of y has to equal the sum of the two it doesn't touch. So 39 and 49 is what's it? 88, I believe. So if that's 88, then the x value of x has to be 92. Exactly. That's exactly what my brain was thinking. Shut up. On 14, you got z has to be 115, x has to be 65, y has to be 65. Hi, how are you? I'm great. Thanks for asking. She's absent today. Adios. So that gives you 65, 65 and 84 is 149. And then add that up, you get what, 31? Is that right for 31?
Yeah.
Thanks. Encouragement. Where's your sheet?
Where's my what?
Your sheet.
I got this.
I think out of all the ones that were done here, 15 is usually the one that takes a second or so to realize what. In number 15, you have a couple of properties that happen. So one of the things that we talked about, in order to show that you've got lines that are parallel, you have to have certain angle pair relationships that occur. Well, notice in the first transversal all the way on the left, you've got two right angles. That transversal is perpendicular to two lines. So whenever a line is perpendicular to two other, those other two lines have to be parallel. Okay? So then when you go through, when you're trying to figure out what A is, you make your tick marks, and you try to see whether or not they line up. If they line up, they're congruent. If they have one tick mark and one non-tick mark, it means they have to be supplementary. If they both don't have tick marks, they would have to be congruent also. So here you'd have to have 5a minus 43, 7a minus 17 is 180. Combining like terms, you get 12a is 60. Minus 60, excuse me. And I had a student second hour, they were talking about, well, but when I substitute in 20, it makes that the angle on the top smaller than the angle on the bottom. It doesn't look like that. It's not drawn to scale. Just like but kids complain. No, never. And then same thing with B. When you make your tick marks going through, they wind up matching because they're alternating exterior, so they have to be equal. So you get 8B, 11B, minus 30. Move things around. And B is 10. Once again, if you remember the properties, whenever you're dealing with parallel lines and whatnot, follow the tick marks to make sure that they match up. If they do, great. If they don't, they're going to be supplementary. Okay. So far, so good? Not too terrible? It was usually the one, that first part about the 90 degrees that most people forget, because once you have two things that are perpendicular, you have to be parallel. Up here, you're looking at crooked. You okay? That's exactly what I thought you were saying. You all right?
Yeah?
Okay. I was just making sure because you kind of had that little.
Oh, I didn't do that.
Oh, you move up
So where?
wherever you want. I don't care. I'm gonna make assigned seats for second semester. Yeah, you guys annoy me. I haven't had to do it in a long time. Chapter 4. Chapter 4 was the one chapter that seemed to take us the longest to get through because we had to actually start working through with proofs. And as you walk through with proof stuff, we had to do a lot of definitions and a lot of setups and what to do next step, that kind of thing. So as you go through this, you guys have all done all the definitions. You know all that kind of stuff. I'll talk about what the proofs will look like here in a second. But the rest of it is, do you know what side looks like? Do you know what side looks like? Can you identify it from a diagram? Things like that. For this next one, find the value of x. It's the same problem we just did a second ago about an exterior angle. Angle on the outside is equal to the sum of the two it doesn't touch. So when you put that together, you know that the 6x minus 7 has to equal 103 minus x plus 2x. The outside angle equals the sum of the two it doesn't touch. You get 22. The next group is when you start looking at the diagrams themselves, trying to decide whether or not you have extra information you can mark up in order to show that you have congruent triangles. And we've done this a ton of times. And you guys know that it's relatively easy just to pick up and look at the diagram and figure out, all right, what do you have, what do you need to show, that kind of stuff. So as you go through, what do you have to mark in the first one? Vertical. You mark vertical angles, what do you wind up with? Angle, angle, side. What do you mark next? Figure out what it's called, but you're probably meaning this. When it's a shared side, what is that called? Reflexive, good. So you got the reflexive, so that gives you what? Another bow tie picture. Hey, remember when I said a lot of times when you see that bow tie style picture, what are you going to wind up with? You wind up with vertical angles. What do you get? Angle, side, angle. 5, what do you get here? Hypotenuse leg, good. That's an example of hypotenuse leg. Hypotenuse leg can only occur if you've got a right triangle. Here we've got the right triangle, so we've got the right angles. Hypotenuse is always across from the right angle, and you've got one of the legs. I'm glad you agree. Might be too loud if you're yelling it that loudly. 6, can you do anything? 7, what do you have to do? Vertical angles again. You get? Whoa! That's one of those, yes. You get it right eventually. We just keep going at it, It's like, what is it, a monkey at a typewriter will eventually type the Magna Carta, Declaration of Independence, all that. Enough time. Thanks. And then lastly, what do you have to mark again? As you see, these are pretty quick. Go to the very back page of the review packet. And this is where you get the idea of what the proofs are going to look like. So the proofs on the final, they're going to be in algebra 1 there's going to be a geometry one. And they mirror the same style as what you see here. So, bless you. What we've done is we've kind of simplified it out a little bit in terms of how it's going to work with the multiple choice. And you get like what we're going to call the reason bank. So those 5 reasons, you might use all of, you might, well, obviously you're not going to use all 5 of them, there's only 3 parts, but if there's 5 of them there, you might use one of them, you might use only 3 of them, you might use 2 of them, you might repeat one of them, things like that. You just have to decide which one are you going to use. So as you go through, bonjour. We're so happy. Oh. Oh no, you gotta sit on the floor. You alright? So when you're going through these things, remember, it's a matter of looking at each individual step. And I know you guys can do these things. You can do that in your sleep. I know that. Yes, you can. Yes, you can. All right? So if you're looking at it from 3 times the quantity x plus 1 equals 24 to the very next thing, 3x plus 3, what did they do? Yeah, they distributed out the 3. Yeah, unplug your earphones. I've been talking about this for a minute. Thanks. So of course, the very first step here is to use the distributive property. Next, what happens from 3x plus 3 equals 24 to 3x equals 21? What did they do? Yeah, they subtracted the 3, so you would use A for addition subtraction property. Okay? The next one, they went from 3x equals 21 to x equals 7. What do they do to move the 3?
Yeah.
From 3x equals 21 to x equals 7?
Oh, sorry, I was at 1.
They use division. So your order here is just distribute, subtract, divide. You can see how that works. All right. Same thing with when you're looking at the actual geometry version of it. When you're doing the geometry version, what was the one thing I tried to tell you guys to do every time you see a proof with given statements? What do you always do? Yeah, you always want to mark your diagrams. So when you're starting a problem like this, before you read anything, before you're reading anything on in this problem, you immediately read what's given. In this case, you're given that A and C are congruent, so you mark it. And then it says that X is the midpoint of AC. Going to my diagram, I mark it. If X is the midpoint of AC, that happens. Now, the last thing I can mark here is, if you notice, that's another one of those types of diagrams that looks like a bow tie, doesn't it?
Yeah.
Which means probably what's happening somewhere in there. Vertical angles. So I'm going to mark my vertical angles. So just by looking at that diagram, I know those 2 triangles are going to be congruent because of what? Oh, what do I have marked? Angle, side, angle. I know that these are going to be congruent because of angle, side, angle. So now I'm going to look at what they were giving me. So the first thing is obviously given. The next one, they said that AXB is congruent to CXD. Well, AXB, well, that's this angle here. CXD is this angle. Why are those angles congruent? Because they're vertical. Because vertical angles are congruent. Why is AX congruent to CX? Why did we mark them earlier? Midpoint. But why are the triangles congruent? Angle, side, angle. You already wrote it down. See how easy this is? And then why are other parts congruent after triangles are congruent? Ladies and gentlemen, there are 7 questions on the final regarding proofs like this. Yeah.
Is that how it's done?
Yeah, it's right. You just look freak, yeah. But seriously, guys, if you really go about thinking it with the terms of the proof here, this is probably the easiest part of the entire test. All the answers are right there, and you know how to flow through something like that. That's 15% of your grade is this. Yes, ma'am. Yeah, grab my stuff, right back there, just sign that. But I'm serious, guys. What do you call it? The proofs, they mirror the same thing. Okay? They mirror out the same way. Back to where are we at? 4?
We just finished 4.
Back to 4. The last little bit in chapter 4 talked about different types of triangles, isosceles and equilateral. And when you're dealing with isosceles and equilateral, you have rules. Okay. Equilateral triangles have all sides that are the same, and what do all the angles equal? 60. So all your angles have to equal 60, so you're going to have 4y. Gentlemen, enough. You set it up like that. Okay? Because they're equilaterals, they're equal angular. Same deal on 10. On number 10, when you have isosceles triangles have congruent legs. Those legs look at the congruent base angles. So if you've got congruent legs, they're pointing towards the angles that are congruent. So if I've got a 59-degree angle in this lower left, I have 59 degrees in the lower right. They all have to equal 180. That leaves me 62 from there. Vertically going back up, if that's 62, that has to make the other sets of angles 59s.
Whoa.
Okay. And it's okay to have two different triangles that have the same size angles, because they don't necessarily have to have the same size sides. All right, we actually talk a whole bunch about that and why that occurs. Second semester we'll talk about this. I think in the very first chapter about similar figures. Okay. What does y have to be in the next one? 65. 65 plus 65 is how much? Subtract that from 180, then you get 30, so this gives you, what, 50 from here? And then lastly, on 12, since all the angles are the same, all the sides have to be the same, which means all the sides have to equal how much?
24.
24. So you set each one of them equal to 24, and you get some very quick math. You get 8 and 12. Okay? Not so scary, terrible, bad. Super exciting. I can sense the excitement. It's helpful. Is that the right word? Sounds good. Chapter 5 has the weird vocabulary. Chapter 5 is the vocabulary part that a lot of us have issues with. What I wouldn't say that it was overly difficult, but it was trying to keep things in check in terms of what certain things meant. For example, we're talking about a couple things. First one I want to look at is this thing called concurrent. Points of concurrency are when 3 or more lines run into the same spot. That's what that meant. Then you had medians, altitudes, bears and lions and tigers and things, oh my. Equidistant, things that were equal in distance. Median. The median was a segment that was drawn from a vertex to a midpoint. An altitude was a segment that was drawn from a vertex to a right angle. The mid-segments of a triangle were the ones that, the 3 of them connected midpoints. Then you had the circumcenter, incenter, centroid, and orthocenter. And that was dependent upon which one of them met where. Now, a lot of these ones that as we got through, you probably realized that it wasn't as scary bad as what you thought. Because as you get going into some of these math questions, I hate to say that you can assume some stuff, but every once in a while you could kind of make an educated guess as to what you're supposed to do just by looking at the picture. These guys are the mid-segments of the triangle because they connect all the midpoints. Now, if the perimeter of the large triangle is 96, remember, if this whole thing is 2, that makes each one of these how much? 1. Which makes this side equal to 1, so on and so on. So as you go through that, that means that the smaller triangle that's inside there is going to have half the perimeter.
Yes.
So what's half of 96? 48. 48, good. That all has to add up to equal 48. Because remember, each of those side lengths is half of what the other side lengths were. So if you're adding up congruent parts that are half going all the way around, it means the perimeter itself has to be half. So you get 3, 4, and 2. Add that together, you get 9x. You wind up with 9x and 3. Some real quick math here, you get x equals 5. With any luck, it's not too scary. But it's the idea that you remember that that triangle that's created on the interior is going to be equal to half the size of the triangle that's on the outside. Because each of the side lengths are half. I thought that was kind of weird. Excuse me. This next one is one of those types of problems that if you forget vocabulary, you can probably take a good guess as to what's going on. For example, it says that 80's in altitude, and what's it? BE's in medium. You got that one? You guys are all weird and shish about it. That sounds pretty good to have a shish about it. Or if you stay have shish kebabs. What's that? Yeah, no. So remember, altitude is height. So remember when your parents told you always to stand up straight? I was just there. You couldn't have finished 2 seconds ago. Oh. Don't worry, I'll get the chair. I like to rest. Christian, are you done yet? Good. So it tells you, if your mom and dad tells you to stand up straight, that means you want to be as tall as you possibly could. It means you create a right angle. So this has to equal 90. Median. If it says it's the median, that means it's kind of the middle of the road type thing, which means it has to be the same amount on both sides. So you have 5x plus 15 is 90. You get 15 when you do all that. Same deal on the other part when you're working with median. If you set those two equal to each other, 4x minus 25 is 2x plus 5. Subtract 2x, add 25, you get 2x. And lo and behold, you're correct because they both wind up equaling 15. Oh wait, give me one. Huh? Nope. Yeah. How do you put angles or sides from smallest to greatest? What's the rule? Just trying to figure it out. Nope. Yeah, remember the smallest angle has the shortest side length. The shortest side length has the smallest angle. So if AB is 3, BC is 4, and CA is 5, which angle is across from the shortest side length? C. Then it goes to A, and then it goes to B. Those are the order in which they would go. It'd be angles C, then A, then B. Oops. Small. Right. Same thing works if you're talking about angles. If you want to put the sides into order. Well, if I'm using the same basic diagram, I say that A is 30, B is 60, and C is 90. Where's the smallest side length? BC. The next smallest side length then would be AC, and then therefore the largest side length would have to be AB. Nope. Next field, you got to ask Loft House. That next door. What's long base 3 of 3? Do I have to do the other two problems? Yeah. Fontana and I were talking about problems like these earlier. I know that we're kind of, we don't want you guys to just go ahead and start assuming things all the time because of the whole ass and math thing. But when you start looking at the diagram and you completely, totally forget how to math, when you're looking at that, what should you do with those two values? Yeah, set them equal to each other. Because that's by rule, that's what you're supposed to do. But if you're just looking at it going, I'm not sure. But in this case, you kind of get away with it. Because also, if this is an angle bisector, since that's an angle bisector, these guys have to be equidistant from the edges of the side. So they have to be equal. 7x equal 7x and 3, 10x minus 9. 12 equals what, 3x? On 10, the top point there is on the perpendicular bisector. And one of those things that we talked about when you're on a perpendicular bisector, it actually creates isosceles triangles. So again, those two have to be equal. You get 9 halves or 4.5, however else your calculator decides to spit out the answer. Right. The answer is 1 on that. Centroids. Centroids were the ones that took us the longest to figure out because they had the weird